if you have white paper, the first question is the study of why objects move as they do and the forces that cause the motion. Yeah, you would think it's kinematics because that's the name of the unit, but mechanics is broken down into kinematics and dynamics is the one that tells us about forces, which is what we are currently, the unit we're working on. So unfortunately, many of you just went with your gut and was not right in that situation. And that's the same as question number two, right? So 1 is, the answer is B, and if you've got green, then it's number 2, and it's
B.
It's also B?
Yeah.
Which one is dynamics?
Dynamics is B.
B?
Yeah.
Okay. Okay, number 2, convert 80 kilometers an hour to meters per second. There is absolutely no excuse for you to get this question wrong. I told you the magic number, I told you the rule, and you have a cheat sheet. Okay? Get it right. Kilometers per hour to meters per second is divide by 3.6, and there's no debating it. Okay? It's the same page, it's number 4. All the multiple choices are on the bottom. So question 2 is A, and if it's number 4, then it's what?
I have no idea.
It's the one that's 22.
C.
Okay? You divide by 3.6. Get your cheat sheet out. Make that change on your cheat sheet right now. Do not make that mistake ever again. That's an easy fix. I'll have a look at it later, Dave. That's an easy fix. Don't make that mistake again. You have a cheat sheet. Use it. Numbers 3 and 4. Number 3 was the one that goes like this. The correct answer is B. Okay, this is negative velocity. I can tell it's negative velocity because it's below. No, I can tell it's negative velocity because the slope is negative, right? The slope is negative and it flattens out, so this is negative velocity, positive acceleration. It's slowing down. The correct answer is B. If you have the green one, the correct answer is A. Okay? Those were from the day when we did the little ticker tape dot fix. Okay, number 4, given the velocity time graph, what type of motion is this? That is clearly a graph that is velocity, and it's constant velocity, and it's above, so it's positive, and so it's positive velocity, no acceleration. D.
C for green.
And C. Okay?
Okay.
Number 5 is a position time graph, and Matt's going to find it for us there. It looks like it's number 10. So 5 and 10 are the same. Okay, it says given this position time graph.
What one is this? For the green?
Okay? Delta x means change in position from 0 to 3. From 0 to 3 seconds. How much did the position change? It's a graph of position. So what's the position here? 0. And what's the position here? 1. So the position change is plus 1.
That's all you had to do?
All you got to do, man.
Everyone got it wrong.
But wouldn't it, don't you take the points on the x-axis, not the y-axis?
No. Delta x means the position change.
Oh, yeah, that's right.
Yeah. B, the average velocity between 3 and 5. 3 and 5 is this bit here. It's average velocity, so we're looking for slope, so I need to find the slope of that. This is at 3, 1. This is at 5, 8. There are still several people in here that do not know how to calculate slope properly. That is something you need to solve. Okay? If you don't know how to do this, put a star beside this and come and see me and get this problem fixed. You must be able to solve for slope, and you have to do it efficiently. You cannot be spending 10 minutes on a question like this. Okay? It's going to be 8 minus 1 all over 5 minus 3, giving you a slope of 3.5.
You need to do V bar equals D for slope.
Well, that's basically what you're doing.
Yeah.
Okay? C, the V inst at 7 seconds, you're looking for slope, because it's a position time graph. It's right there. The slope is clearly 0.
This right here, you got,
It's instantaneous velocity. Velocity is the slope of the position time graph, and the slope of this is clearly 0. And D, during which intervals is the object moving to the right? It's moving to the right when the slope is positive. So there and there. And oddly enough, a lot of people wrote 1 to 3 and 3 to 5. I don't know why people thought it started at 1. I didn't deduct because it's obviously 0. But I noticed that. It's 0 to 3, these two intervals here. Some people labeled them A and B. That was awesome. Okay? I'm hoping by the end of this you will realize that I don't care so much about the answer, but the process is important. If you can show me some understanding and you get your answer wrong, you're going to get some part marks. If all you show me is an answer, it sometimes isn't good enough. I don't care about the answer. I want to know how you did it. Okay? So please keep that in mind. Okay, number 6 is the drawing one.
17 on
Okay.
that one.
17, Katie tells me. A girl gets on a bike and rides at constant speed down the street to the corner store. Along the way, she stops for a red light. When she gets to the store, she goes inside. On her return, the light is green. I made this out of 6. It says 3. I changed it because I think these are worth 2 marks each. Okay, it's a better indication of what's going on. Okay, so I'm going to start with position time graph, and I would suggest that you do the same. Most people assume that where she starts is her 0 point. She travels at a constant, she might speed up a little bit. She travels at a constant speed. Then she stops for the red light. Then she goes at a constant speed again till she gets to the store, where she stops. And then she returns home without stopping. Lots of people had this part still going this way. That's positive, right? You got to come back home.
Where's that?
Oh, then
2 check marks.
you can do that right.
2 marks. Okay, now the velocity time graph. Velocity is simply the slope of the position time graph. So let's do an analysis of the slope here. Positive, 0. Positive, 0. Negative. Graph that. Positive slope, 0 slope, positive slope, 0 slope, negative slope. Positive slope, 0 slope. Positive slope, 0 slope, negative slope. You're graphing the slope of the position time graph. And the same thing holds true for acceleration. Let's do a slope analysis. 0, negative, right? I mean, it's almost straight down. This should probably be at a bit of an angle. Negative, 0. Positive, 0. Negative, 0. Negative, 0. I'm figuring out the value of the slope. 0. Down, negative. Flat, 0. Up, positive. And then I graph those. 0, negative. 0, positive. 0, negative. 0, negative, 0.
That looks funny.
Funny, haha. Number 7, uniform motion.
Green. 8.
8 for green. Uniform motion is traveling at a constant velocity. It is not increasing. Increasing is uniformly accelerated motion. Uniform motion refers to moving at a constant speed. And a good example is a car on the highway traveling at a constant speed.
You said it's not an increasing velocity?
Nope. Uniform,
You marked on mine increasing velocity.
it's not increasing velocity. You may have said it's increasing velocity. And the velocity time graph for it, because it's constant, would be flat, not straight, flat. Okay, if it's like this, then that indicates increasing velocity. Okay, so that's question number 7 or 8. Did I miss it? In all of these word problems, it's extremely important that you write the formula. I cannot stress that enough. Some of you made up formulas that I never showed you. This is why, if you write the formula, every time you do a practice question, you'll get them right. Okay? Please, I'm begging you, write the formula. I write the formulas every semester. All right? If I can do it, you can do it. All right, so we've got a bowling ball leaving the hand of a bowler at a speed of 2.6 meters per second. That is my initial velocity. My initial. When it reaches the pins 1.1 seconds later, that's my
Yeah.
time.
Or time, sorry. And your PS.
It's traveling at 2.15. That's my final velocity. What is the acceleration? So the first thing people go, oh, what's the acceleration? And they write this, A equals delta V over delta T. And then they realize they need to do what?
Find delta V.
Find delta V. And so then they do this. Now why is that, why is that wrong?
Delta A.
Because I read from left to right. I don't know that you wrote this down and then went over here, even though I do. Don't do that, okay? If you write this down and you make a mistake, oh yeah, I need that other one first, erase it. Make your things go in the proper order. If I showed you how to do questions the way you guys showed me how you do questions, you'd have no idea what was going on. Okay? Use the eraser, stop being lazy.
If you write left to right, top to down, like my acceleration was under that, but I had delta V.
Yeah. Yeah. Okay? So, oh yeah, this should have been delta V, right? So it's going to be delta V is VF minus VI. 2.15 is equal, or minus 2.16. I got to rewrite this. And you get minus 0.45. I see countless people that do this. I don't know why people do that. They write and they go on this crazy diagonal thing. Or they do this. Or they do this. Places all over the place. It makes no sense. What I need you to do, I'll get to you, Logan. What I need you to do is I need you to line up the equals. Your formulas should go vertically like this. Okay? I should be able to draw a line like that. And everything is inside those two lines. I'll get to you, Logan. Put your hand up. Okay? You got to get into this habit. No! This is the way you do it. Now, I'll get to you, Logan. Now I'm going to go over to here. And this minus 0.45. Now I take my minus 0.45 and I put it in for delta V there. Minus 0.45. My time is 1.1. And I put my answer minus 0.409. And that's meters per second squared. You'll notice that this is out of 2 marks. That's a very strong indication that you need 2 steps. And quite likely, 2 formulas. Okay? You might not think this is important, but it is hugely important. And what I'm going to do for you is I have a grade 12 test that I'm going to show you a question on, and you can see why it's so important. Okay? You've got to get into this habit. And I have this conversation every year with grade 11 students. Okay? That is my job, to train you to do this. And I will. Number 10. How long in seconds does it take a car to accelerate from rest to 55 at 3 meters per second squared? Notice that it's number 14, thank you. Notice that it's worth 2, once again indicating that there are 2 steps to the problem, 2 steps to the solution. Hopefully,
14.
you should recognize that it's 55 kilometers per hour, which means you have to do what?
Divided by 3.6.
And please write 55 divided by 3.6. So I know what you know. If all you give me is an answer, show me your work. You don't need to tell me that. I've already seen it read. 15.278 is what I have.
It's okay if we only have to choose.
Okay? Then you're going to write A equals delta V over delta T. 3 equals 15.278 all over T. Now, this is a problem. If you don't know what to do with this, you need to get this straightened out immediately. Okay, this is just basic algebra solving here. The T goes up there and the 3 goes down there, right? You need to be able to do this.
Why is it 9?
No, that's the A.
Oh.
Sorry, the acceleration is 3, right? I'm
Yeah.
trying to show you what's going on here. Okay. The 3 and the T switch spots. If you don't know that, you need to practice that over and over and over and over and over until you get it. It's so important. It's got to be automatic. No thinking. Automatic. Okay? So T is going to be 15.278 all over 3. And your answer is 5.093. You'll notice, once again, 2 marks. Okay, let's go to number 11. Katie, you got it figured out?
15.
11 and 15.
Just kidding, it's not.
It's not, you lied. Yeah, I know.
Counting on you, Kish.
9.
11 and 9?
Yeah.
Good. How long in seconds does it take the car to accelerate from oh no, hang on, wrong one. A ball is dropped from a cliff, right?
Yeah.
Acceleration due to gravity is minus 9.8. Acceleration is minus 9.8. If the ball lands after 5.25 seconds, what is its final velocity? VF. What does VF equal? Now, there's one other thing that you're told that you might not realize. It's dropped from a cliff, which means the initial is 0. The initial is 0. What is the final velocity? I'm going to write A equals delta V over delta T. Minus 9.8 is equal to delta V over 5.25. And you've got to be able to solve this, like, just know it, automatic. Delta V is, this just becomes a multiplier, right? And it's minus 51.45. That is delta V. It is not the final. It is not the final. VF and delta V are only the same numerical value when... Exactly, and it is. But you have to tell me the final velocity is minus 51.4 to get the second mark. And that, of course, is meters per second. 13 is a drag racer.
6.
Thank you. 13 and 6.
I know what I messed up on this one.
Again, 2 marks.
Here's the silly little mistake.
You got to take 175 and divide it by 3.6.
Yeah, for some reason I put 200 in time.
48. Yeah, you got to write the formulas. You got to. It's so important. It's so, so important. Okay, the average speed is 48.6. Your D is 200. Again, the T and the 48.6 switch, that's got to be automatic for you.
Yeah, for some reason I put the 200 in the T spot.
4.1 seconds. A lot of you make silly little careless errors like that.
Yeah.
And you know what? Practice. Practice your problems and you don't make them. Okay?
Next question. This one.
So the next one is 14. All right, let's move to number 14. What did you say, Kate? 14 is what? 11. Okay, 14 and 11. Gage, I need you to watch here, right? A sprinter finishes the 200-meter race in 20.82 seconds. Calculate his average velocity. This is probably the easiest question there is out there.
I got it wrong.
What's the displacement? 200. What's the time? 20.82. 9.6 meters per second. Again, let me point out vertical lines. Okay? Some people do this stuff. This drives me nuts as well. How am I supposed to know which one is the answer? Okay? Don't do that. Take your time, do it nice and neat, show me that you know what's going on. It's important. 15 is the same as it's 7. It's the position time graph that looks like this. And it asks for delta x from 0 to 10 seconds. And it starts at 6 and it ends at 10 seconds here at 1. Look carefully. 1. So the displacement is -5. It goes from 6 down to 1. It's a position time graph. What position is it at 0 seconds, Regan? 6. Well, I went through it. V bar from 0 to 10. That takes the next step. You've got the displacement already. What's the change in time? So that's going to be -5 over 10 seconds, or -0.5 meters per second. V inst at 7. You need a tangent line. If there's no tangent line, you're not getting the mark. It's as simple as that. It's a position time graph. I'm asking for velocity, so I need slope. It's curved. I need a tangent line. You've got it on that big chart that I gave you with all of what to do, right? So the slope is approximately -0.67. Somewhere in that range I took, as long as I saw a tangent line somewhere. And this is known as variable motion. Okay? D asks for A bar from 0 to 8. A bar is slope on the VT graph. 0 to 8 is that slope, right? 0 to 8. I had to find the slope. It's up 7 and over 8. .875. 7, Regan. Up 7. Yeah, but what did I say? I said up 7 and over 8. Don't just write numbers down. Listen to what I'm saying and engage. Don't just write numbers down. That's
Realize what I did wrong for
E. A inst. Acceleration on a velocity time graph is slope, and because it's a curved line, I need a tangent. And if I don't see a tangent, you ain't getting a mark. I need to see a tangent line. And I got something around 1. Anything around 1 with a tangent line is going to give you the mark. F asks for the instantaneous velocity. It is a graph of velocity, so we simply read it off the graph. I left it at -4.7. I accepted 4.6 or 4.8 as well. G I omitted. G was the same as E or C, and I didn't see the point. I don't even know. I didn't work it out. You have to find displacement. Number 17 is number 5. Okay, this one is a position time graph. Down, up, down. Delta D means change in position. From 0 to 4, it goes down 5, -5, -5, down 5. From 4 to 7 is +2. It goes up 2, right? From 0 to 7, it goes from 0 to -3, -3. There, from there to there. And the last one, V bar from 0 to 11 is there. V bar, really? I'll double check. V bar is from 0 to 11, okay? And it's V bar, so it's slope of the position time graph, so that's up 2 and over 11. 2 over 11 or 0.18. Quickly, the bonus. Acceleration is 1.7. How far does it travel during the 7th second? 0. 0, 1, 2, 3, 4, 5, 6, 7. Which is the 7th second? There's the first one, the second one, the third one, the fourth one, the fifth one, the sixth one. The 7th one is between 6 and 7. Okay, between 6 and 7. So you need to know how far does it go between t is equal to 6 and t is equal to 7. In other words, I need to know what the average velocity is for that interval. And the only way to get average is to find the initial and the final. And so I go delta v over delta t. For 6, my velocity at 6 is equal to 10.2. My velocity after 7 is 11.9, giving me an average velocity of 10.2 plus 11.9 all over 2, an average velocity of 11.05. And how long is that 7th second? Well, it's only 1 second long, isn't it? V bar equals d over t, and I'm hoping you can do this in your head, because it's times by 1. 11.05 meters. That's a hard one.
Not really, if you have,
It certainly shows that you have good understanding. Okay, there are really only about 4 or 5 categories of questions on this test. They are, the first page I'm going to call theory and definitions. Okay? I want you to write these down on the back page, on the back blank of your test. Theory and definitions, questions 1 to 4. Are there any other questions on this test that you would categorize as theory or definitions?
No.
I disagree. Question number 7 is clearly a definition. What is uniform motion?
It's like 7 years.
7 is the what is uniform motion, or 12?
What about 8 then too?
Yeah, and
7 and 8. And if you've got green, it's going to be? Which ones? What's the uniform motion and 3 things, an object position? What are they in green? Look them up.
12.
12 and? 12 and 13?
8.
12 and 8. Okay. Theory and definitions. I want you to figure out what your score is out of 4, 3, and 3 is 6. You got a score of 10 on theory and definitions. What is your score? The other type of question is what I'm going to call drawing from a story. Drawing the graphs from a story. In other words, question number 6, or question number whatever this one is. Right? What's the one we had to draw? The girl on the bike. In green.
17.
17? So question 6 or 17. It's out of 6. Write down what your score is. Okay. The next 3 categories are what I'm going to call word problems and formulas. Then there's position time graphs. And there's velocity time graphs.
So are these all
Okay? Those are the other 3 categories. Your homework for tomorrow is to figure out what questions are word problems and formulas, what questions are position time graphs, which questions are VT graphs, and tell me what your scores are on those 3 categories. That is your homework for tomorrow.